What's up, everybody? I'm Dumb Dave, and I'm dumb as a bat. Or I'm blind as a bat intellectually. But if I'm as blind as a bat intellectually and I can kind of understand how they work in echolocating little bugs in the night, then so can you. Let's dive right into that. So, what is even echolocation? It's when a tiny little bat sends out an ultrasonic signal like this. And that signal bounces back. Uh-huh. And you got that, you get that, you get that. Giving the animal or the bat in this situation information about the environment. Other animals do it like dolphins, porpoises, whales, beluga whales, and even some mammals, terrestrial mammals like a shrew, I think. And also humans can do it. Watch. Yeah, just saw the color of the walls. No, but like blind people can actually develop that. Um, if we could see over here, not all bats do it though. Megachiroptera, about 30% of bats, a whole 150 damn species, like fruit bats. They're the cute bats. They're not the ugly bats. They don't echolocate. But Microchiroptera, so the little ugly bats with the ugly little faces, they do 800 species. 1 in 5 mammal species is bat. I didn't know that. I didn't know bats were so prolific and they had so many species. Yes, so as we can see, bats, the reason they're so good at this is their ultrasonic capabilities. We can see how humans right here, we can hear about 20 to 20,000 hertz. And, or kilohertz, whatever. And as we call it ultrasound because as soon as humans can't do it, then it's ultra because we're the one learning all of this. Um, we see beluga whales, even mice and cats and dogs. They can hear those really high frequencies. That's why sometimes your cat or your dog will be like, "Huh," but and then you're like, "What are you crazy? Hearing nothing?" And my battery's dying again. Um, yeah. So let's take a little bit. Let's take a little bit of a look at their hunting capabilities. How do they do it? Well, they do it in 3 steps. They're searching, then they approach, then they do what's called a terminal buzz. Searching is when they're just shooting out pulses every now and then. They're just like, what's over here? What's over there? Nothing is interesting them. They're just gauging to see if there's any prey. Approach is when they're like, I think there's something over there. So what you see is they actually start clicking a little faster. And then 3, the terminal buzz, they start clicking so fast it's like a buzz. And that's when they're like, okay, they're honing in their prey, beep 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 beep, like that. And they eat that little bug. But let's look here. There are 2 types of signals that these bats do: FM and CF, frequency modulated and constant frequency. And you can see because constant frequency, they're just longer, it's more constant. You can see the differences in frequency and the characteristics. These are more like sharp bings, and these are like like that. Let's delve into those 2 types of things a little more now. So FM is used when you're trying when you're you want more detail and more and uh, this is bad. Distance. Oh, so FM is better to gauge detail and distance of something. CF is better for motion. Um, FM you would use if you're in a crowded forest with a bunch of trees. CF you would use if you're in an open field trying to see where the forest begins. Don't lose the forest for the trees. So let's get in. let's get into let's delve into what we call a duty cycle and pulse duration. So here in the blue right here, we could see we have the duration of the pulse. We can obviously see that FMR short, CFR long. And in the light blue, we have the echo. It's the exact same duration, just delayed. With the gray lines, we are showing the 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 length of the pulse. And what we call a cycle period is the beginning of the first pulse to the beginning of the next pulse. And a duty cycle would be the relative ratio of pulse duration to cycle period. In the pink, we have the cycle period. Did I say before that's what the cycle period was? May have missaid it. The cycle period is the beginning of the first one to the beginning of the second one. And the duty cycle is the ratio of pulse duration within the cycle period. So here in CF, we have about like a 70% duty cycle. Here, we have about a 30% duty cycle. And they use all this information to figure out different things. So based on the amplitude and delay of a signal, that's going to be able to tell the size of a target. Using binaural time cues, so that the microscopic differences in left to right auditory signals reaching the ear, the bat's going to tell the horizontal position. Now, using the echo amplification differences plus the moving ears of the bat, she's going to be able to figure out the vertical position. I think I spelled that right. And then Doppler shift, she's able to get the relative position. Is she getting closer? Is she getting different? Doppler shift. Remember that when an ambulance goes, that's the Doppler shift because the waves are getting longer. Also, like the red shift in the universe, how you're able to know that the stars are moving away and the universe is expanding based on a red shift, longer wavelengths because they're getting stretched out. It's the same thing here. The echo pulses are getting deeper, so it's like, that bug's getting away, I gotta move faster, or vice versa. Okay, so that's just basically what they do in their signals. Now let's go into their little baby brain. So here's their auditory cortex, and obviously the most important part, the only part we're really interested in right now. We see there's 4 parts. See, because this is now this. We see that there are 4 parts, but there's actually really 3, but this part has 2. They have specific areas for each type of call. Look at that. And notice how tiny and little baby this is. 1 micrometer? Yeah, I'm familiar with that length. Cut that out. So let's zoom in here on the FM area. The FM area has a map. It's kind of coded. Neurons in this region respond to FM type auditory input, but in order to get a strong response, the input has to occur as a pair of sounds with short specific intervals between them. They are combination sensitive neurons. The neurons spike in response to the echo component of the pulse echo pair, but different neurons in the region respond to different pulse echo intervals within the range of 0 to 20 milliseconds. In this way, the different neurons code for different target regions. It's like a map. So remember the 3 stages? The caudal part is responding for the search. So the long delays are here. And as you get closer to the target, each part lights up until you catch the little baby bug. It's very very interesting. So here, remember the delays, the duty cycles, the blah blah blah. Those are important because different parts of the brain are literally understanding, are firing the closer you get. Wow, that's interesting. Okay, now let's go to the CF area. Honestly, trying to understand it, and I'm not there. So we'll skip it. Activity in the CF area encodes relative velocity information. There are two regions, but only the latter is shown here in detail. Individual neurons respond to a combination of particular frequencies depending on their location in the map. Dotted lines. At, whoa, I'm bored. Anyone else bored as hell? Oh. Anyway, next over here we have the Doppler shift area. Um, as we can see, bats have a preference for a specific frequencies. Um, yeah, whatever. Next, last part. For the brain's too complicated. Forget about that. Dog bone tiger moth. This is just one example of an animal that has evolved and developed tactics against the bat's genius echolocation strategy. If we can go all the way back over here, we notice another type of moth, but a moth that only makes noise in an ultrasonic sound. So the 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 dog bane tiger moth does the same thing. It jams the bat signal by producing similar frequencies at the bat, obviously disrupting the pulse echo delay, throwing the bat off. He's like, what the heck? These guys are genius little chirpers. They go, "Bark, bark," jamming the bat signal. I think that's awesome. And yeah, here's the most surface level understanding of the neuroscience of bats echolocation. Join me next time for either something